Hello, welcome back. According to JAMB syllabus, these are the four objectives. These are what you are expected to know under equilibrium of forces. So, we are going to convert this into questions, and that's all for you. Once you can master these questions, you are good to go for the JAMB. And this is what we call reverse engineering. I've always been shouting that you can predict accurately 99% what Jambo asks you if you can lay your hands on the syllables, but many people they are just not serious. So these are four objectives for this topic. But because the topic is a bit large and there is a theoretical and calculation aspects of it, I'm going to divide this video into two. So this is part one, the theory aspect. I'm going to work on part two. For part two, I will require a board. And so I don't have it now close to me, but as soon as I get it, I will make part two of this video. Let's go right into it. So we are talking about the equilibrium of forces. We are talking about forces that are balanced. Remember those days when you used to play in school, when you used to do tug of war? Yes, when the forces are balanced, like in this image, then we say that object is on equilibrium. The rope will not move on either direction. So that rope is in equilibrium. The forces on the left hand side equal to the forces on the right hand side. That means the forces are balanced. What if your opponents are stronger than you? What will happen? They will pull you. So it means that the force they applied, the total sum of force they applied on their own side is greater than the total force you applied on your own side. So that makes it unbalanced and it causes acceleration. There will be a change in direction of that rope. The rope will move to their direction. That is to say the forces are unbalanced. So whenever the forces are unbalanced, it means that uh, there will be a change in direction of that object. Please note this. I've seen a lot of questions on this. Once the forces are not balanced, what happens? There will be a movement. There will be acceleration. But if forces are balanced, there will be no movement. What happens when you keep a book on the table? It doesn't move. It remains there. But there is a weight on the book that should have made the book to pass down through the table. But the wood also provide force that keeps it on that position. All right, so these are basics. Like I said, this video is just the beginning. There are calculations that I'm going to do on another video. So you should be able to define force. These are basics. Push or pull on an object. You should be able to give an examples of forces, the gravitational pull, the friction, and so on. You should be able to know that force is a vector quantity because it has magnitude and it has direction. Unlike scalar that have magnitude without direction. I hope this is very clear. One thing you should never forget is the unit of force. Okay, so I've already explained balance and unbalanced force, but let's look at these two images very quickly to solidify something. I've already explained the tug of war example. So look at the other image. A woman pushing a wheelbarrow, a man trying to shoot, or he pulled an arrow, and a man holding a magnet. The magnet has a force of attraction. Then fruits falling under the force of gravity, friction, a man sliding down, and acceleration, a woman with tire shoe. I be what they call them. So sliding or running on a smooth road. So in each of these six different illustrations, the forces are not balanced. There is a push. The force of pushing the wheelbarrow, the force of pushing is greater than the force that is trying to oppose it. That is the weight of what is on the wheelbarrow. So she is able to pull it, to push it. Assuming the weight is so high and such that it is equal to the force of the woman, she will not be able to push that wheelbarrow. So the simple logic you are to know here is that when forces are equal, the object will remain in its position. But when the forces varies, the object must change position. I hope this is clear. So for balanced forces, the forces cancel out. The forces are equal size and they are in opposite direction, so there is no change in motion. On balance, the forces doesn't cancel, so the object accelerates or it changes direction. So Newton's first law is associated with this balance and unbalanced force, and he says that an object will stay at rest if forces are balanced. So the summary of the law is that the object will remain at rest provided that forces are balanced. Okay, so let's quickly look at these examples. This is a box in the middle. The arrows indicate forces acting on the box. Now, vertically, we have 50 upwards, 50 downwards. Horizontally, we have 30 left, 30 right. Now, will this object be at rest or it will be in motion? The answer is it will be at rest because the forces acting on it, the opposite forces acting on it, are equal, so they will cancel out. 50 upward, 50 downward, the net or the resultant force is 0. 30 left, 30 right, the resultant force is also 0 because they will cancel out. Both are pulling or pushing in opposite direction with equal amount of force. So the object would remain at rest. It won't move at all. Though the forces on directions differs. For example, we have 50 upwards, 30 left, 30 right, 50 downward. But what we are considering is that the opposite forces up and down are equal, left and right are equal, so the object will still remain at rest. But if there is variation in opposite forces, had it mean we have 50 up, 30 down, then there is problem already. The object will tend to move towards a greater force, the direction of greater force, which is 50 rather than 30. But since 50, 50, 30, 30, the object would remain at rest. So I hope this is very clear. Please, the way this kind of questions come, if most times they would draw a diagram and they would ask you to tell what would happen, what the effect of the forces would be, or they would ask you to add. Okay, so I hope this. Okay, a lamp hanging on a ceiling is in equilibrium. Yes, because the force, which is the weight trying to make it fall, is equal to the force that is trying to keep it in position. Hence, the lamp hanging on a ceiling is at equilibrium. I hope this makes sense. All right, so let's go. What are the conditions for an object to be at equilibrium? You have to know this, please. You have to know this. I have seen several questions and I'm going to put some real JAMB questions for you at the end so that you can see and you would work them as assignments. So when the net force of an object is 0, the object will be at equilibrium. So this is a condition. The net force must always be equal to 0. If the net force is not equal to 0, then an object will move. Assuming two persons are pushing a car, maybe the car refuses to start and they call you and your sister or your brother to come and push the car. What happens? Let's say you apply 10 Newton, your brother applies 5 Newton, and you are pushing it. Remember, in this case, the two of you are pushing it in the same direction. So the resultant force will be the addition of your forces, you and your brother's own. So that will be 10 plus 5, which is 15 Newton. So, and we are expecting the car to move if your force is greater than the force that is keeping the car at rest. Now, imagine on the other hand, you are pushing the car with 10 Newton on the towards the front direction and your brother is at the opposite end pushing it in your own direction, what do you think would happen? This time around, instead of adding, we are going to subtract because the two forces are opposite. When forces are in the same direction, you need to know how to resolve them. If they are on opposite direction, you subtract. If they are in the same direction, you add. That is what will give you the resultant force. So the major condition for forces to be at equilibrium is that the forces, the sum of the forces must be equal to 0. That is, the force to the right is equal to the force to the left. The force to upward is equal to the force downward. I think this is clear. Okay, here is a clear illustration of what I'm talking about. So look at these two, the first image up there. The two are, one is pulling, one is pushing actually, but in the same direction. One with 150 Newton, another with 100 Newton. So what is the resultant force? The resultant force will be the sum of their forces because all the two forces are acting on the same direction. On the contrary, the second image down there, one is pulling at 150 Newton and the other one is pushing opposite. You can see the red arrow there pointing opposite at 100 Newton. So what's the resultant force? The resultant force is the difference. That's you subtract the smaller from the biggest, and that's what will give you the resultant force. So 150 minus 100 there gives us 50 Newton. So these are the addition of vector forces. In the second video, I'm going to talk about vectors in an angle, and we are going to introduce some rules to resolve those kind of vectors too. So how forces add up? Forces are vectors, add them head to tail. Okay, I think I've explained this clearly. In equilibrium, vectors form a closed shape. Okay, yes. I think I saw a JAMB question like this. Very interesting. So it is something you need to know. In equilibrium, vectors form a closed shape. That is, the net is equal to 0. Horizontal left force equal to right force. If you vertical upward forces is equal to downward forces. Oh, very interesting. So we are having we have types of equilibrium here. We have what we call stable, unstable, and neutral equilibrium. I remember I answered this question in JAMB 2012. Was it 2012? Yes, I think so. The same image as it is like this. They will label it A, B, C, and they say which of the following is at equilibrium, stable equilibrium. Can you imagine? So it's just, and this is a very simple question. All you need to is to know. So when we say an object is at stable equilibrium, it means that if you tilt it, if you move it, if you displace it, it will come back to its position. Look at this funnel, for example. If you apply this little force, your finger, you just tilt it using your finger. What will happen? It will move, and if you remove the force or withdraw the force, what happens? It comes back to its own position. That's what we mean by stable equilibrium. Different images may be used, please. Different images may be used, and they may not even use any image again. They may use different ways. For example, why is it that a stable equilibrium object comes back to its position? Because it is stable, because the force of gravity is acting around its center. So if the force of gravity is not around its center, it tends to move towards the force of gravity, as in the case of neutral equilibrium. So please, I want you to master this. Just understand it. If this is not clear, the comment section is there. Our WhatsApp group is there. That's why they exist. So please feel free to ask any question that is not clear. So for unstable, which is the second image, if slightly moved, the object accelerates further away and it changes its point or its starting point or its location. In the second image, if you try to use your finger to tilt the image, the object, what happens? It moves away, it won't come back, unlike the first one. So that's what we call unstable equilibrium. Then we have neutral. In neutral equilibrium, if you slightly move, the object stays in new position with no force pushing it backwards or away. So look at that image. If you try to push it with your finger or with any object, or you just apply force, what happens? It will move slightly and stay in a new position with no force pushing it back. There is no force pushing it back like in stable equilibrium. It will move and stay in a new position. Now look at closely. The only difference between between unstable and the neutral equilibrium, the difference is not much. In the unstable equilibrium, the object accelerates further away from its starting point. Further away from its starting point. Meanwhile, in the neutral equilibrium, the object stays in new position with no force pushing it back to its position, as the case is in the stable equilibrium. I hope these differences that I have explained are very clear. Please, 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 if it's not very clear, just let me know. All right. So yes, so here are your assignment questions. You are expected to submit today. Yes, today, before 10 p.m. If you are my student, please submit. If you are not my student and wish to do them, you can just use the comment section and talk to me. I can add you to your group if you are interested in joining us. We are on a journey of preparing for JAMB 2026, and our goal is to score 300 plus. So if you want to join the challenge, kindly let me know in the comment section so that I will find a way to add you. If you wish to do the assignment too, you can do it and then submit it to me privately on WhatsApp, and we continue. So on this assignment, you have 8 questions. I'm going to send this on the group. Yes, I will send the PowerPoint on the group so that you can have access to the questions. Or rather, when you watch the video, just send me a DM. I will send you the PowerPoint, because some people are not serious. Let me not be wasting my time. So only those that watch I will give the assignment to do. Thank you very much once again. As usual, I would always want my students to help me improve. Was my explanation very clear? Was it to your understanding? Was I fast? Was I slow? Was I normal? So please, I would like you to use the comment section to just give me a feedback. An honest feedback will help me a lot. I have a goal, I have a target to get as many as possible students enter into the university without writing JAMB the second term, and also get their courses of choice. And if I'm not communicating, there is problem. So I just want you to drop something, especially if you have watched to this end. I really appreciate you. It's not everyone. Some people might have started and they just drop at the end. So it's not easy. It shows commitment. It shows readiness to learn. Because if you can't keep yourself to learn, if you can't discipline yourself to stay at it, you can't go far. So thank you once again, and I appreciate you for staying. Please don't go without giving me that review. Very important. And if you've not subscribed to this channel, I have a lot of videos on this channel educating that will help you in your JAMB. Subscribe and then scroll through to see videos that will be very helpful to you in biology, chemistry, physics, and also in areas of how you can score JAMB very well. One video I would always want you to watch, and I would always advise you to watch, is how you can predict JAMB questions accurately. I'm going to drop the link in the comment section. I will pin it on the comment section. Please make sure you watch that video. Meanwhile, don't forget to drop a review. Thank you and bye.